Okay, so for this video, it's just going to be voiceover, and I'm going to use the whiteboard here to try to talk a little bit about the background of how sulfanilamide even came about. So before 1938, the great elixir disaster of 1938, sulfanilamide was a known effective agent against streptococcal infections. It was first discovered by Joseph Jacob Gelmo as part of his PhD dissertation, and it was patented in 1909. So there's our patent. Now, what sulfanilamide looks like, let's see if I can do this. Let's see if I can try this straight line thing and if this is going to work. How this works. Try to make my line straight. Oh, that won't let me do a straight line there. Okay. That was interesting. All right, I'll go back to here. That's supposed to be a benzene ring. There's my benzene right there. All right. And then I'm going to put an H2 here. And this side gets a little funky. I'm going to put a sulfur here, that's the sulfanilamide. And then we're going to have a double bond oxygen, and an amine. So that little bugger right there is sulfanilamide. And like I said, it was patented in 1909, and it was a really kind of an interesting compound, but they didn't really know what to do with it. If you wanted to look up the modern chemical abstract service number for sulfanilamide is 6374-1. And you can go on Google that CAS number and get all sorts of fun stuff, facts about sulfanilamide that you may not have known. But I want to talk about this history. So that happened in 1909. We have this patenting of sulfanilamide, but there's no use known for it at this point. It's just this compound that was discovered. He wrote it up in his dissertation and patented the compound. Meanwhile, Bayer, the inventors of aspirin — aspirin is actually their brand name, but it became into common usage — Bayer was working on things derived from coal tar. So it was realized, I think it was in Oxford, but in England, that you could take coal tar, and it was the product of making coal gas, a byproduct of making coal gas, which was used to illuminate the streets and houses. So this coal tar byproduct turned out to have a lot of different organic molecules in it, and it became really key to the dye industry. A lot of the dyes that we still use today originated from coal tar. And at Bayer, they started working on if some of these dyes had antibacterial activity. So are they antibacterial? So they're looking at these various dyes, asking if they have any antibacterial activity. The lead was for Bayer was Gerhard. Let me make sure I'm going to just butcher his last name. That's supposed to be a D. Gerhard. Let's just try that whole thing over again. I am failing here, but that's okay. I'll just start it up here. So, okay. Gerhard, and his last name was Domagk. He was the lead of the research team. He actually received the Nobel Prize for his work in medicine in 1939. And remember, the great sulfanilamide tragedy was 1938. But he and his group came up with this Rudd compound, this dye that had an antibacterial activity. It wiped out Staphylococcus. They injected it in mice in a murine model, and it wiped out their staphylococcal infection. And this compound they made they called, Steve, even back then, we have great drug names. It's called Prontosil. Prontosil. So this red dye was called Prontosil. And let me draw the structure of Prontosil for you here. We're going to start with our little amine here, and I actually put my sulfur up here. This should start looking familiar, double bond O. Here we still have our benzene ring just like before, but here's where it gets a little different. We're going to come down here and have a nitrogen bond here, and then we're going to have a second ring here, and then this ring is going to have an amine here, and it's going to have an amine group here. So Prontosil, this stuff kills staphylococcal infections. It winds up being very effective in mice. Boy, Bayer sees what all pharmaceutical companies want to see, even back then: money. Money, money, money to be made on this drug. So they started marketing Prontosil as this great antibacterial. They patented Prontosil. Things are looking great for them until 1935. In 1935, the Pasteur Institute in France, I actually almost got a job there. I was looking at becoming a microscopist there right after grad school. The Pasteur Institute, three scientists, Fournier, M-E-A-U, Jacques, and T-E, oh, I messed that one up. Let's go back. T-R-E with a little schwa there, and then it's F-O-V umlaut L. I'm not going to try to butcher their names. They looked at Prontosil and figured out that Prontosil was actually a prodrug. That is, Prontosil was not responsible for the antibacterial effects. Instead, what happened is we had our Prontosil, and I'll put my sulfur here, my double bond O, my guy here, and that's a 2, and then we're going to put this guy down to my benzene ring, and then this guy's going to go to my nitrogen, down on nitrogen, and then we're going to go to my benzene ring. And let's see, I know we have an amine here. Let me look at my notes and see where the other amine is here. I think that's pretty close to Prontosil. It turns out it's a prodrug. That is, it gets metabolized and turns into sulfanilamide. This part is freed, and you wind up with this guy becoming, let's see, I'll do my amine here. I'll draw it this way. That way I can just look at my notes and not have to think about this too hard. Double bond O, and then another amide group. So you can see basically everything is there for this, and this is the active form of the drug. Well, that meant for Bayer the end of all that money, because this sulfanilamide was patented in 1909. Now, they kept on making it, and they started making sulfanilamide, but that meant that any other manufacturer, like Massengill, for instance, could come along and start making this guy because it was already off patent. Even though this guy was patented, it didn't matter. All they had to do was make the actual drug, not the prodrug. So I think that's all I really wanted to say about the earlier history of sulfanilamide. I just kind of thought it was interesting how we discovered it. Sulfanilamide does have a huge place as being one of the first, if not the first, sulfa drugs. So you can see these dates are right before World War II, and sulfa drugs played a very important role in saving lives in World War II, saving soldiers from these terrible infections. So, all right, have a good weekend.